Today we're doing the third set of notes on statistics, and we're going to talk about determining the mean of normal distribution versus skewed distribution. So at the top of your page, notice it says distribution and normal distribution. So distribution would be data, a graph or table. That represents data. So a graph table that represents data. A normal distribution is something we talked about already, and this is when your data looks like a bell curve. So your data follows the shape of a bell curve. And when your data is distributed normally, the mean is located in the center. So we kind of talked about this the other day when you have a histogram and the bell curve is on there. So if we were to estimate the mean, you would locate the center of the bell curve and you would drop a line straight down. So for this problem, I would estimate the mean, I want a little crooked at the bottom, to be 4. So remember, the mean is this letter U with a longer side. So we would say the mean is 4. So what we're going to talk about next, and this is the next page, so I skipped a couple examples, so go ahead and flip to the next page, is when we have data that is skewed. So data that is skewed is when data falls further to one side than the other. So notice, looking at these two graphs at the bottom, I have a left skewed picture and a right skewed picture. Notice the vocab word is kind of opposite of what you see. So for my left skewed picture, notice most of your graph is happening to the right of the function or of the table. And then whereas the other one, most of my data is happening to the left, this would be an example of a right skewed. So notice when I go to the tip of the peak, that's no longer your mean, that is your mode, and that's the number that happens the most frequent. So then essentially you kind of go like 2 deviations off, and that's where your mean is located. So it's kind of like that area where, notice it's pretty steep and then it starts to plateau out. That's where your mean is going to be located. All of these answers are going to be estimates, so it's okay if we all don't get the exact same answer, but we should all be in the general vicinity of one another. So here's our first example. So you would take the picture, and the first thing you'd have to do is draw the curve on there. It's okay if you cut off some of the corners of the rectangles. You just want to make the picture match your data as much as possible. So what I would do is draw a line coming down from the peak, or the center of your graph. So that is not the mean, that is our mode. And then we're going to go about 2 deviations away. So I'm going to go 2 deviations over. So I would say my mean is roughly 2.1 based on how I drew it. So again, I would accept an answer maybe anywhere from 1.98 to 2.3. Anything within that region, I would say, is a good estimate of your mean. The next one, I believe it's on the next page for you guys, is a distribution of minutes spent exercising by 18 to 24-year-olds. State whether your graph is skewed to the left or to the right. So because most of my data is happening to the right, this is what we call left skewed. And the next thing we've got to determine is the mean. So again, to do that, we would draw our picture on there. Let me get a different color. So here's the peak, so I would drop that straight down, and then I go about 2 deviations away. So I would say my mean is roughly 195. And let me get a different color. So I would say my mean is 195. And again, these are estimates, okay? if you are slightly off the mind, but you shouldn't be, and for an example, like give him an answer of 220 or 225 is completely off. That is on the opposite side of the graph. It shouldn't, not even close. So that's the basis of these notes. Obviously, I have plenty of other practice problems in this set of notes, but we are not going to really focus on those. We're going to jump right into the study guide from this.